As always, make sure that you pause the video and give the question a shot first before you listen on. In order to find the direction cosines and then later the direction angles of the vector given in question 34 here, we want to take a look at the equations that give us the three direction cosines. And so here are those equations. They're going to be giving us eventually three direction angles, alpha, beta, and gamma. And we can see that in order to determine the direction cosines shown here, we need a couple of values. We need the components of the vector, which are given to us in the question itself. So for example, a1 would be 6, and a2 would be 3, and then a3 would be -2. But we also need the magnitude of this vector, and that is symbolized in the denominator by this absolute value of vector a. And the magnitude of a vector can be obtained simply by taking the square root of the sum of the squares of the components. And so as an equation, it would look like this. Notice we're squaring the individual components, summing them, and then taking the square root. So we'll go ahead and plug in the three components, a1, a2, and a3. And if we carefully crunch that down, we're going to have 36 plus 9 plus 4, and that works out to 49. And then, of course, the square root of 49 is going to be 7. So for all three direction cosines, we're going to be using 7 in the denominator of each. And then for cosine alpha, we will use the x component, which is 6. For cosine beta, we'll use the y component of 3. And then for cosine gamma, we have the z component of -2. And so this is the direction cosine for alpha, this is for beta, and then this is for gamma. And in addition to finding those direction cosines, we have to find the direction angles. But that's a straightforward matter, because to find the direction angle alpha, we simply have to take the inverse cosine of 6/7. And then we will be doing the same thing to find beta as well as gamma. So we'll go ahead and set up those inverse cosines. And if we type this into our calculators, making sure we are in degree mode, we get roughly 31 degrees for alpha. Looks like about 65 degrees for beta. And then for gamma, 107 degrees. So these would be the correct direction angles. And then just for a little clarity to get a better idea of what we just found, this is not actually drawn relative to the vector that we have solved in this question, but we can see that we drew an arbitrary vector that we've labeled A. And what we basically just found were the angles that lie between that vector and the x, y, and z axes. And so we can see that alpha right there would represent the angle between the x-axis and our vector. Beta is the angle between the y-axis and the vector. And then gamma is the angle between the z-axis and our vector. Again, this picture didn't necessarily correspond to the vector in question. This was just to provide some clarity as to what we actually found in this question. Thanks for watching. If you liked the video, please click the thumbs up and then also subscribe so you can stay tuned for similar videos. Remember that you can send in your own question to the email address shown on the screen, and I'll do my best to post the answer to it on YouTube.